today about collection system operation maintenance tools. I guess the term I like to keep using with people is you have a lot of tools in your toolbox, and not every tool in your toolbox is the right tool for every job. So we'll talk here about the different tools you have in your toolbox and how they might help you with your projects. With sewer cleaning, we've got jet cleaning, we've got vac cleaning. I talked to a lot of people about, gee, can you come to my town and do some cleaning? Well, what kind of cleaning do you need? Do you need jet cleaning, or do you need it's a jet and vac? A lot of people don't appreciate that. Well, gee, you dragged the nozzle through it, it must be clean. Well, all you're doing is pulling that stuff down from the high points of your system and the lower points of your system. At some point, you've got a system full of crap. Especially if you've got a small community and you've got a nice big interceptor running through town. At some point, all you're going to have is your main interceptor in the middle of town is going to be half full of stuff. And sure, you drag a jet nozzle through it, but it's not always going to be clean. And one thing to consider is when you're going to be hiring somebody, always specify that you have the work done per the NASCO JET or Code of Practice. Then you know you're getting the work done and accomplished per a nationally recognized standard. Sewer inspection. We've got a lot of advances in sewer inspection over the years. Microprocessors have gotten better and better and better. Look at how much computers have come in the last 30 or 40 years. Well, why does it do that? What we're recommending is you get your sewer inspection performed per the NASCO PACP, Pipeline Assessment and Certification Program. The national standard of abbreviations and codes for sewer inspection. A lot of people have had sewer inspection going on for the last 30 or 40 years, and everybody coded everything differently. Some people call it a crack, some people call it a fracture, some people call it a break. And you'll try to bring all that data together at the end, and what you've got is a bunch of stuff, and nobody's really sure what you have. So really, what we recommend is if you're going to have sewer inspection performed, have it performed per NASCO PACP. Then you're going to get the same code for the same defect regardless of which person does it. The standardized data format. The data is going to be recorded digitally in a standardized data format. Therefore, if contractor A does one half of your town, contractor B does another half of your town, you can combine all that data together into one uniform report because all the data is recorded digitally in a standardized data format. You've got software vendors that write the software that do PACP compliant work. So if you're going to get PACP compliant work, it's going to be done with compliant certified software vendors. Guidelines for mapping and data results, basic assessment protocol, training and certification program for the operators. This is just one page out of the PACP code, which for each defect. Each type of defect has a specific type of code. So you've got, over here, you've got fractures. Well, you've got longitudinal fractures, circumferential fractures, multiple, and I can't even read that, spiral. So this is the standardized data format, or standardized coding for each of the defects. And if you do this, what you're going to get at the end is you're going to get a report that looks the same from every PAC compliant contractor. Now obviously our logo is going to be on the top of this one, somebody else's logo is going to be on the top of the other one, but the rest of this information is going to look uniform from contractor to contractor to contractor. It's going to be easy to deal with because everybody's going to call it the same, your reports are all going to look the same, and electronically all the data is going to be able to merge together and be sorted. The NASCO also has a manhole assessment and certification program, so you can get your manholes assessed and coded with a standardized format. Now, different tools in the toolbox here. There's grouting. Grouting is a way we can rehabilitate manholes to stop the leaks. It's a non-structural fix. Manholes must be in fairly good condition. Now, I know, what does that mean? But I guess what that means is if you've got a brick manhole where it's just like a piece of Swiss cheese, you're going to have to be pumping a lot of grout for this to be effective. But if you've got a manhole like it's shown here in the illustration with a crack, grout is an effective tool for I&I control. Different types of grout are available depending on your application, depending on where it is. I mean, if we're up in Bemidji, we're 2 feet down from the top of the rim, we're not going to be using acrylic type grouts because they're subject to freeze and thaw. So it depends on your application, but different things you can do. Now this is a video that just illustrates how chemical grouting works for manhole rehabilitation. Come on. Oh, this is going to be boring. This is bad. Well, that's not going to work. So what we do with chemical grouting is we drill holes through the manhole structure, and then we pump the acrylamide grout, or grout, in whichever, be it acrylamide or not. We get it on the outside, and then we have it form into a solid on the outside, and then we've got the hydrostatic pressure working with us. Manhole grouting is performed per an ASTM standard. This ASTM standard is a standard practice for sealing sewer manholes using chemical grout. Different types of materials are available. The right one for your job is subject to talking about it, because there is no one right tool here that, oh crap, why do I keep doing that? There is no one right tool here in the toolbox. These are all good tools depending on your application. ASTM standards are written by a committee. Committees formed of manufacturers, consulting engineers, contractors, municipalities. It's a fair, open, level playing ground for you to bid a project to. So if you specify you want to do manhole grouting, if you specify it per that ASTM standard, you'll get a number of qualified contractors, and it's not written to exclude anybody. Sewer rehabilitation using chemical grout, we can just fix the leaky joints in an individual pipe. You know, how many of you have vitrified clay pipe, and the pipe looks as good as the day it went in the ground, but it's leaking at every joint? Well, joint test and seal is a very effective way of fixing leaky pipe using chemical grout. It's a non-structural solution. We consider it to be a permanent repair. Very effective for INI control, cost effective. A lot of people want to do cure-in-place pipelining to go after INI or leaky pipes. Chemical grouting, joint test and seal is about 1/3 of the cost of a manhole-to-manhole segment using cure-in-place pipe. And cure-in-place pipe is a structural fix. It's not an INI fix. So what you've got is a leaky pipe, but the pipe's in good shape. You don't need a structural fix. You need the INI fix. So what you want to stop that leaking. The big restriction though is the pipe must be in good structural condition, because this is a non-structural fix. Now this isn't going to work either. This is unfortunate. Pipeline grouting. Well, I guess I got to explain what the video was supposed to show. So what we have is we take a joint packer that's pulled into place. It's guided by a camera. When the operator positions it over a leaky joint, he inflates the packer to isolate that joint, and then he injects grout at pressure slightly above the groundwater pressure. That grout goes out through the leaky joint, and then it forms a gel on the outside. Now, if you stop by our booth after this presentation, you'll be able to see the videos that you shouldn't be able to see here. What you're doing is you're putting that gel or that seal on the outside of the pipe, and now you've got hydrostatic pressure working with you instead of against you to stop that leak. Pipeline grouting has an ASTM standard. It's this standard. It's everything you need to have in a good spec for pipeline grouting is going to be in that. So just reference that standard, and you're going to get a level playing field for good qualified contractors to do pipeline grouting in your community. We can do lateral connections using pipeline grouting. It's the same, this is that packer, except with laterals, we've got this third lateral packer that puts our seal here. So when we pull this into place, we inflate it, we've got a seal here, we've got a seal here, and then we launch the lateral bladder and we've got a seal up here. Now you got 3 points of seal we can inject that material and it goes out through these leaky joints and forms a gel on the outside. Now this is what you're looking for, something to that effect. And we can seal up those joints. This is very important if you're trying to do cured-in-place pipelining on a leaky pipe. Well, every time we do this, we put a nice cured-in-place pipeliner in, and every time we open up a service, all we do is open up a spot for that infiltration and inflow to just come running back in. So in conjunction with the cured-in-place pipe project, you're going to want to look at doing some kind of a sealing system. Now this is chemical grout. There are people out there, or we don't have it, so I don't have any pictures of them, but there are people that have little cured-in-place systems that can be launched from the main. We got things that can be launched from the house. There's all kinds of different things that are trying to go after sealing up that location after the cured-in-place pipelining goes in. Now here's another video that should be showing you how that works. I wonder if I can get that. Alright, I'll have the mouse go here. Okay, so this is that lateral grout video. So we've got our grout truck, and then we've got our power winch at the remote manhole. So this illustration already shows that we've already gone through and we've lined the leaky joints. Now we're going to go after this leaky lateral connection. So this is our camera, this is our lateral packer. So the operator positions the lateral packer over the lateral, rotates it to line it up, and then he launches well at first he inflates this, then he launches the lateral grader. So he's got his point of sealing here, here, and here. Now you can inject that grout, it'll go all through these leaky joints and stop that infiltration and inflow. Okay, lateral connection grouting has a ASTM standard. Again, same rules apply. It gives you a good level playing field for any competent contractor to bid to that standard. One thing to think about with lateral connection grouting is cast iron pipe. We need to get a good solid seal with that lateral packer, that third seal that goes up the pipe. In the cases where we've got cast iron pipe, it's typically not smooth enough to get a good seal. So all we do is we pump grout up somebody's lateral. So typically, if we're in a case of cast iron pipe, we can't grout those. Roots are a problem, and we have to get a good tight seal. So if you got a lateral that's full of roots, we're going to have to get those roots out of there, or we can't do that. And then any kind of mineral deposits in a lateral, again, same thing. The last thing we want to do is launch that packer up there and not have a good seal. Pump 10 gallons of grout in somebody's lateral. Now we got to get it out, get it back in service. And another thing to note is residual grout will be present. It says may be present. It will be present. A properly sealed lateral using this technology will leave a thin film of grout on the inside of the lateral. Don't be alarmed. Eventually it'll slough off and it won't affect your collection system in any way. It's basically the consistency of Jell-O. And again, you can swing by the booth and stick your finger in it and you can see if you think that's going to affect your system. Manhole lining. A lot of people have old brick manholes with the brick in pretty decent shape, but the mortar's starting to go. You know, there are cementitious products applied any number of different ways. to rehabilitate an old manhole. These things typically have a 25 to 30 year service life. Just keeping an old brick manhole in service. It's a structural monolithic repair, good for eye control. Looking at somewhere in the neighborhood of 30-year design life. And there's this ASTM standard for that. So if you go ahead and want to do this kind of work, make sure you reference the ASTM standard. You get a level playing field for any number of qualified competent contractors to quote this work. In cases where you've got extreme conditions in manholes, you have to get into sometimes epoxy coatings, high acid resistant coatings, force main discharge manholes, lift stations and the like, where you've got really aggressive hydrogen sulfide atmospheres. You get into doing an epoxy top coat on your manholes. There is no ASTM for manhole lining with epoxy. So if you're dealing with that kind of system, you're going to have to reference the manufacturer's info. Epoxies have to be installed over a relatively smooth surface. So if you've just got an old brick manhole and you say, gee, why can't you just spray epoxy on it? Well, it's got to go on a relatively smooth surface. And we're typically dealing with something in the neighborhood of 80 to 125 mils. 80 mils on brand new construction, sometimes like the lift stations, we know it's going to be a problem. We put 80 mils of epoxy on going in. Rehabilitation work, we're dealing with somewhere in the neighborhood of 125 mils, or 1/8 of an inch. And then typically, if we're going to do epoxy, typically we're putting a cementitious cure or liner underneath it. We're usually dealing with a 24-hour cure time on something like that. Epoxies are typically in that neighborhood of 6 hours. I mean, it varies from manufacturer to manufacturer, but those are just typical numbers for you. And typically, epoxies have to be applied in temperatures 30 to 40 degrees and rising. It depends on the manufacturer. It's just typical numbers. Epoxy lining for new construction to think about. Force main discharge manholes, lift stations, big interceptor sewers where you're punching out into an area. You know you're going to have, you're putting in this interceptor. It's designed for 20, 30, 40 years down the road. Well, you've got no flow in it today, so you got this really bad high hydraulic resonance time. Your hydrogen sulfide goes up. We're seeing a lot of people with brand new interceptors that are eaten up by hydrogen sulfide before they ever get near their design flow. And it's less expensive to put epoxy on when it's brand new instead of rehab. Gonna have to be moved quick here. Pipelining, what can be lined? Now this presentation is really written around cure-in-place pipelining. But if you've got a pipe that looks like this, we can't do cure-in-place pipelining on that. Pipe like this, as bad as this looks, and your report's going to say broken, cracked, pieces missing, all those bad things. But we can do cure-in-place pipelining on this to rehabilitate it because it's still basically a circular hole through the ground, and we can run a cure-in-place pipeliner through it. Now this on the left, could you slip line that? No. But we could pipe burst that. Now pipe bursting, you're going to either go to a smaller pipe, pull an 8 into a 10, or you can go 10 into a 10, or even a 12 on a 10. That's the real big plus of pipe bursting, is you can upsize. Well, you'd be able to get a burster through that. So you'd be able to work with that if you want to go with pipe bursting. Pipelining, again, this is written for cured-in-place pipelining. It's a fully structural permanent repair. It's trenchless, very quick. If we're doing a steam cure line, we can do 2 blocks a day. We're in and out. People are back in service in a matter of 6 to 8 hours. We can go through material changes, size changes, and we can go through alignment changes with the cure-in-place pipe. Cure-in-place pipe is specified to an ASTM standard. Make sure you always reference the ASTM standard when you're doing cured-in-place pipe projects, and you'll get a good quality project. We can do rehabilitation with spot repairs or section liners. If you've got that one bad spot right in the middle of the pipe, maybe you had your cable telecommunications company came through a horizontal directional drill right through your brand new PVC sanitary sewer. We can come in and fix that single spot with just a short 4 or 5 foot repair. It's very, very similar to the ASTM standard for cured-in-place pipe. Just the one thing to understand is it's not exactly the same. So if you want to specify sectional repairs, just specify the applicable sections of F1216, and you should be okay. The F1216 specifically describes inverting a pipe using air or water pressure, and the pipe will be inverted by people and manpower. So that's one of the big differences. The other difference we usually use in sectional lining is we use a epoxy resin instead of a polyester resin. But if you specify use the sectional liner with the applicable sections of F1216, you should be pretty confident of getting a good job. Design consideration for cure-in-place pipe. We have to know if you're going for the partially deteriorated or fully deteriorated design case. Typically, we want to design for the fully deteriorated case because we're designing this to carry the full load, assuming that the host pipe is completely failed. We have to know the soil density because we have to run through some numbers for the calculation. So if you're going to do a cure-in-place pipe job, we're probably going to be asking you for questions about, well, what kind of soil do you have in your area. We have to know the groundwater load. We have to have an idea of the depth of bury. Ovality reduction factor takes into account is how far is it gone from a circle when it was originally put into an oval. And at some point, it gets so much out of round and into an oval that we can no longer cure-in-place pipeline it. So if you've got pipes in the ground and they're starting to get to be a nice big oval, the time is now to start thinking about doing something because it might be too late. And then we got to know any live load or surcharge. When you're talking about specifying cured-in-place pipelining, I like to point out that cured-in-place pipelining is not slip lining. Slip lining is a different technology. When we're talking slip lining, we're typically pulling in high-density polyethylene. There are other processes for pushing in different pipe products, but slip lining and cured-in-place pipelining are two different processes, and you really shouldn't reference them in your spec. If you've got any references to fold and form pipe in your spec, those are references from about 20 years ago when companies were trying to get around the original patents for cured-in-place pipe. But you probably want to delete those, any references to fold and form pipe out of your specs. And if you are going to do lateral replacement in conjunction with a cured-in-place pipe project, we'd recommend that you do lateral replacement after the main line is lined. Because if you do your brand new plastic lateral replacement and then we come by with a cured-in-place pipe liner, now we've got to open that service back up with a little router bit, and it's easy to follow a clay service around, but every time we touch that plastic with that router bit spinning at, I don't know, 10,000 RPM, bad things are happening to that plastic. So it takes extra time, extra care, and I don't care who you are, it's difficult to do. So we recommend you do it afterwards with an insertity. And with that, take any questions. Doesn't look like I got to do many questions.
Any questions?
I got one. With that grout, if you have root issues, what's the, with that chemical grout, you said you can grout it. Is there some way you have to remove the roots?
Well,
does it keep the roots out, or is it just a never-ending?
If we're going into a pipe to do test and seal, and we'd have to mechanically remove or chemically remove the roots first. We can't go into a pipe that's full of roots. Okay, we can't go in because it won't work, number one, and secondly, the clearance on the equipment is very tight, so we couldn't even get the equipment past a decent-sized root mass. So you're going to have to mechanically or chemically remove those roots first. Now, if you've got a joint with root intrusion, and you're going to fix the leak with chemical grout, we can add a root inhibitor to the grout, but I'll tell you, it's not going to be a permanent fix. I always say if you've got really fine roots, there's a good chance those fine roots are probably going to be killed and cut back. But once you get to decent medium-sized roots, at some point they're going to find their way back in. Any other questions? Yes, sir?
On the test and seal, do you have to bypass for that?
No. For test and seal, the packer is a flow-through packer. So we can do that under full flow conditions. No problem.
With that, let's give him a round of applause for a job well done. If anyone has any questions, I'm sure you'll take the questions, but our next speakers are ready to go. So